over the next couple of minutes. So thanks for joining, everybody. I am Peter Leese. I direct the TraCS Data Science Lab. This is the first of monthly seminar series that Data Science Lab will be giving throughout 2024, every third Tuesday of the month. And today, both as our first of the year, as well as actually our first really Data Science Lab seminar that we have done since the Data Science Lab started, I'm really starting with an introduction to the Data Science Lab as we sort of move from a very soft open into a much more full and public open state. And so to really understand the context of the Data Science Lab, it's necessary to give some background on the CTSA, both locally and nationally. Oh, you are seeing a notes view?
I think if you do display settings, it says to swap it, maybe, at the top.
How about now? No. Same.
There you go.
No, you're good? Okay, good. So just as a bit of a background for CTSA, CTSA is the Clinical Translational Science Awards program. This is a very large biomedical research investment from the NIH, now through NCATS. It's by some metrics potentially the largest biomedical award really ever instantiated. And it's really designed to support and create infrastructure for clinical translational research throughout the entire country. So the way this was created was really site-specific awards awarded through NIH, beginning in the mid-2000s with a small number of sites. And today, really moving up to a total of 60 sites throughout the entire country. Let me just move. And as you can see at this point, the sites really span the entire continental United States with clusters and certain specific high density areas. So the Northeast, California. At UNC, our CTSA award started in 2007. We were one of the early awardees. And TraCS does many things. The CTSA was founded as TraCS, the TraCS Institute. And I think many people think of or know TraCS as sort of a portal for accessing EHR data. But TraCS and the CTSA really does many things with sort of different foci at different sites. There are services to support clinical trials, recruitment and retention, various sorts of education and training for a variety of both research and kind of support roles, evaluation services, and informatics. So different sites have a different focus on informatics. Some is really, much more informatics and even software development kind of focused. Other sites has been more analytic or biostatistical focused. But at NC TraCS, the TraCS Institute, just to give a sense of the various services, as well as sort of the broad sort of size composition, informatics really probably is about the largest unified service within the CTSA Institute. So the IDSci program, TraCS's Informatics and Data Science Group, consists of 4 teams: EHR Data Services, Development and Infrastructure, Project Management, and the Data Science Lab. And then you can see off to the side all of the other sort of various services and groups within the TraCS Institute that perform all of the other sorts of associated but non-informatic functions under the CTSA umbrella of supporting and facilitating translational clinical research. And to be honest, I tried to represent everything. This might not even represent everything that TraCS does or all the various services. So if I've missed groups or people, apologies. And so just to think structurally about the data science lab before moving into maybe some of the more ethereal pieces like mission and how we achieve some of these things, I wanted to at least show the structure, because so far people have often had questions about how large are you, what's your reporting structure. So the data science lab is led by me, Peter Leese. I'm the director and lead scientist. Currently, we have 2 full-time data scientists, Dr. JP Powers, Dr. Thomas McEntee, and we are currently actively interviewing for our 3rd full-time research data scientist position now. I report directly to Emily Paff, the TraCS IDSci co-director, who I'm sure many people are familiar with, and Ashok Krishnamurthy, the director of RENCI and the co-director of TraCS IDSci, is also often involved in not directly, reporting structure, but often involved in things that I'm thinking about, or Emily and I are talking about in terms of mission or build out, and certainly collaboration. RENCI is one of our early collaborators and someone that we work with closely on many different things. And so to really transition and start to think about, what does TraCS do and what does the data science lab do? It's necessary to understand a little bit about what the existing groups in the IDSci sort of team within TraCS does. So many of you are familiar with the EHR group. This is the group that you interact with to actually access EHR data or Carolina Data Warehouse data. They focus on really building data sets for research, facilitating research through the building of data sets. There's also the development and infrastructure group. Their focus is really on facilitating and building more informatics resources broadly for research. That could be software engineering, DevOps, admin, a whole variety of things. But kind of crucially, these are 2 groups that can function as honest brokers, or groups that can actually provide data for research, which comes up in a little bit later as I talk about the function and how the data science lab will actually operate. But to move into a little bit more of the philosophical and foundational space, why create a data science lab at UNC and why put it in the TraCS Institute? So, at the largest possible level, or really maybe even I'll back up. So, I have been at UNC for more than 10 years. I've really been working academic research for, I guess, close to 15 years. Much of that time, if not almost all of that time, has really been focused in real world data and particularly EHR data. And so really the using of EHR data for science is sort of my main academic area. And what has been pretty obvious, as we've gone through these transitions, particularly beginning in ARA and the American Reinvestment and Recovery Act funding and meaningful use and some really large national sort of legislature designed to really move the nation from lots of paper-based medical records to electronic, is that we've really seen this groundswell in transitioning healthcare and associated work, operations and research, from lots of traditional modalities increasingly into EHR-focused modalities. And what that has led to, in my opinion, very publicly, at least as someone that works in EHR data, are really huge gaps, both at like a local level, as well as clearly a national level across sites and AMCs in real world data broadly, but particularly EHR data. There's lots of interest in using this data for science and operations, but it's very different than other data than people have used. And so, we've had these giant gaps, I would say both, again, at local levels at UNC, as well as, when we talk with peer institutions in accessing data, understanding bias and confounding in data, adapting methods that were validated in other data sources to EHR data. And so, these are now really large enough issues in a prioritized space that increasingly is a real funding and work priority for national science groups like the NIH, that I think we really have to start thinking about addressing them systematically. And so the new CTSA grant that UNC won just in, let's see, it was 2022 or 2023, really provided a large incentive for sort of creating this group that myself and Emily and others have been thinking about for several years. And that's really to begin this CTSA transition from just doing the work of building infrastructure and support for research into actually doing research off of built infrastructure. And so, very specifically, the data science lab at UNC is built to start to address some of these systematic issues and gaps in actually using EHR for doing research and operations, but also in the training of people in how to use these things to do operations and research. So, the other options that are up here, formal education and applied training, really the CTSA grant in many ways provided the incentive and the opportunity. And now the data science lab is really built to address these sorts of large scale issues directly at UNC, but ideally also to kind of develop and formalize solutions for these and supports for these that we want to send back to the national CTSA community as products ultimately. And then thinking about how that works, sort of how you move from the local level down to the data science lab. I mean, from my perspective, I think we really have complementary missions stemming all the way from national CTSA down to the local. So at the national level, it's a very, very broad mission that can be implemented and defined many different ways. And then even you can see in the mission of NC TraCS, it's much larger than informatics, right? To broadly support the translational science community. But you can see then within IDSci how things start to really apply directly. And so truly the goal here is, within the data science lab, for us to be building and doing things that map and support each of these other missions. So directly within our local IDSci, larger group within TraCS, back to the larger mission of the entire TraCS Institute, and then ultimately back to the national CTSA program through NCATS, both in deliverables and manuscripts and science, but also in ideally curriculum and technologies and other types of supports that we can ideally open source and share back with the community. And so the question becomes sort of how do you move to the point of actually instantiating that mission within the lab. So the way we do that is through our work portfolio. And currently, this is the portfolio that I have prioritized. So ideally, 3 equally balanced areas, 1 research collaborations, a 2nd research engineering, and a 3rd in education and training. Over time, these balances might start to be weighted a little more towards one or the other, but at least for the short to mid-term, these are the clear 3 priorities. And I have a couple of examples under each of these, just as sort of a brief, context, but we'll talk about each of these in quite a bit more detail. So the research collaboration area, one of the questions that I have gotten is, why do we focus on that? I think this is probably one of the more obvious areas, one of the clear gaps at UNC, particularly in the areas of both EHR data and using data science to do research, is in actual local research collaborations. And this is where I was saying the CTSA grant, in a bit of a pivot, it has really started to incentivize the CTSA groups and hubs to actually do research as opposed to actually just building infrastructure to support research. This is a bit of a challenge. Just at UNC, this is a bit of a mission change for what TraCS IDSci historically does. But there are associated issues both at UNC and across other sites. So accessing and using EHR data, as I alluded to before, it is different than other types of data. It is hard. It has challenges, not just in the structured side, but in the unstructured side. So things like text and imaging data. Additionally, I would argue that utilizing data science methods and technologies is relatively novel in the biomedical area relative to other areas. Partially that depends on your definition of what data science methods are. But I think increasingly what we see is that many of the core foundational sorts of concepts and concepts and methodological approaches are still relatively new, at least when you look across sort of like a publication space, but also rapidly increasing, just to sort of demonstrate where focus is in prioritization. A really large need and issue that we have, at least at UNC, is getting flexible high-performance computing and computing environments for these types of data sets. And then something that I've also talked about, adapting existing methods. So there are lots of methods from claims data and other areas that people are interested in using. It's not necessarily straightforward to implement those in EHR data. I mean, part of the larger context on this too is I think we're really increasingly seeing some amount of paradigm shift in NIH funding priorities, or at least large federal funding priorities. So really increasingly large focus within grants around things like common data models and novel model architecture and network-ready model architecture, extremely large data sets, right? So not on-prem processable data sets, things that require sort of different architectural approaches, data linkage, novel methods, a variety of things that I think it really requires a new group kind of focused specifically on these things, potentially opposed to existing groups to expand into, to really capitalize on. And really, as I was talking about before in sort of the data science lab, sort of the CTSA sort of obstacles that we were designed to work through. The data science lab is really designed and built to try and address all of these various obstacles, to really, move UNC forward in these spaces, and to really try to more proactively capitalize on lots of these funding priorities coming out for research collaborations. People are often interested to figure out, how do research collaborations work? So the sort of big picture is data science lab today really focuses on two types of research collaborations. To date, we've really spent a lot of time focusing on very large external or multi-site research collaborations. So these are things like the National COVID Cohort Collaborative that we've been working on for 18 months to 2 years, the Recover Project, which is a large sub-project under N3C. And then we've also really applied for or submitted grants that really do very similar sort of national level multi-site networked model informatics and data science hubs for both kidney injury as well as Alzheimer's disease. And so, this is where I say this sort of model of large scale multi-site external research is a model that we have experience with, and that we expect to continue to be a model that we see and try to capture. But we also do support really UNC PI-led research. And so the question is, how do those work? The model that we have is a PI really brings us either a funded project or an idea for a project that they would like to propose, write a grant for, or a proposal to get funded. And then really you essentially buy a portion of a research data scientist to add directly to your research team as a collaborator or a co-investigator. And at that point, you really have embedded access to all of the various services and expertise of the data science lab, all the way from proposal write-up through deliverable, whether that's manuscript or report or sort of whatever the end result is. And so that's really access to the clinical and EHR data expertise, the data science methodological pieces, the compute stack, and then through the academic pieces, right, of manuscript creation, authorship, all of those pieces. The caveats to this are maybe twofold. One is that the data science lab is not a service. So in contrast to something like biostatistics consulting, we are not really set up to do something like a 2-hour power calculation. So we do not really support, we have this one discrete transactional thing. We'd like to pay you, on an hourly to do this one thing, and then it's complete, and we sort of throw it back over the fence to you. So we are really designed as a lab where you really retain one of our staff as a part of your research team for the full life cycle of the project. The other piece to note is that because the data science lab is intended to do research and be part of a research team, really by definition, they cannot be an honest broker on a project. And so what that means is that when you work with the data science lab, there are a lot of things that we can do on your project, but we cannot pull data. That is essentially a requirement just from, federal research funding level paradigms, where there needs to be the honest broker as a level of abstraction outside of the research team. And so just to set expectations when you work with the data science lab, that doesn't sort of leapfrog over other areas of TraCS that you need to work with for other core services. Again, just based on sort of how research requirements are set up and data abstraction requirements are set up. And so people are often curious, what are examples of research collaborations? What are things that we do work on? What are things we don't work on? So these are a variety of example research collaborations we've done, both large external as well as local. So we've done many things in the area of both COVID, long COVID, as well as OMOP, the OMOP Common Data Model, because so much of these large external projects are now run through the OMOP Common Data Model. Currently, we are also engaged on a multi-year project, really originating from UNC, but collaborating with the National Census and looking at aspects of social determinants of health data across various data sources, from census data to EHR data. And then the bottom two are proposals, active proposals that we've written that we have out currently, really looking at one in a specific vascular surgery area and looking at sort of assembling a pretty specific data set that could be templated as a sort of cohort model from a common data model, to many different sites, and then with some associated method development. And then similarly, we have another proposal out that's or in process, I suppose, really looking at also design of a new metric, looking at sort of balancing of EHR cohorts based on data density over time. So sort of giving a sense of some of the specific applications, some of the more informatics, architectural focus, some of the methods work that we either have done or are in the process of doing now. And so to transition from research collaborations to research engineering, I think the question I'm often asked is like, tell me about research engineering. Why is that necessary as opposed to focusing completely on research collaborations? Research engineering is really pretty foundational to everything else that we do. And, I think the tagline here is, so for the data science lab to really build a nationally recognizable leading program in healthcare data science, it will require a lot of infrastructure and both innovation and sort of rollout. But I think the big part of it is this is a place where we can really prioritize a lot of things that need to get built or developed to enhance and innovate both healthcare data science at UNC, as well as things that we're collaborating on with others. To be quite honest, the big part of this that we prioritize are things that I would consider catching up. So I think institutes or institutions that we would like to consider our peers in the biomedical and healthcare informatics space, I would say are further along in things like environments, particularly scalable dynamic environments for very high performance computing. The building of their own centralized secure enclaves and work environments for this type of work to be done indirectly by researchers, as well as the really high quality rollout of I would say, more complex services. So these are things in like unstructured data, so notes, imaging, as well as the associated tech stack to do all of those things. I think UNC has many of the components individually that are necessary to build those, but really to date, they have not been put together to be competitive, I would say, with Johns Hopkins and Vanderbilt and some of these other places. And the data science lab is really, I would say, a primary push to make up space in that area. Similarly with cloud computing, I think cloud computing is foundational to many of these sort of environment and tech stack pieces that we have focused on and tried to make some progress on. I think another really big part is innovation. So part of it is, I would say, trying to catch up, to have similar resources and paradigms as our peer institutions. But I think there are lots of opportunities for us to also innovate with some deliberate prioritization in these spaces. So again, training and education, this is a really big gap, both locally and nationally. And it's something that I've prioritized in the 18 months or so that I've been in my role. So we've already built, with Renci's help, some novel, really kind of cloud-focused, internally built and resourced spaces in their Helix platform, really intended to give people a hands-on training space to doing healthcare data science in really common data modeled EHR and claims data in a way that's much more directly accessible. So we want to be able to facilitate new types of hands-on training in EHR data and common data model data, as well as just sorts of new types of events. So coding challenges, hackathons, in addition to formal coursework, seminars, lectures, workshops, all of those kinds of things. I think there's also a really big opportunity as really nationally, I would say, lots of biomedical kind of healthcare work starts to centralize on OMOP as its common data model of choice, including the NIH, to really enhance what OMOP is capable of, particularly for EHR data that can work both at a local site as well as still be interoperable on a network level. Despite being such a widespread choice, there are still lots of things that OMOP either has not addressed or is just not that good at. We've spent a lot of time looking at and working on those sorts of aspects as a site within N3C. And I think, as we really work to move to a much more OMOP forward sort of data warehousing presence at UNC, at least for research, I think we have lots of opportunities to do interesting informatic and architectural types of research and innovation and publish all of that work, both within Odyssey as well as the more formal academic communities. And then, well, probably I would say the bigger focus is on applications. I do think that there is lots of interesting methodological innovation that can happen and get prioritized through our research engineering portfolio. I've talked about data density as one sort of high need area. I'm particularly really interested also in looking at social determinants of health from EHR data. There are really a wide variety of methodological things that we can look at from an EHR perspective, both adaptation and revalidation of existing methods, as well as completely net new methods, particularly focused on things like bias and confounding, which I would say so far are probably both under quantified and under addressed in EHR data. So there are lots of opportunities in research engineering. And I think lots of really great, both high quality things that will support and innovate this area, as well as lead to really high quality research and publication opportunities. So one specific example I want to talk about that I've personally spent a lot of time on is Ordered. So Ordered is our OMOP research data repository. This is really an entire IDSci kind of initiative that big parts of it I have been leading with our collaborator Renci. And so this is really UNC's attempt to build an entire new environment and platform of a centralized enclave for EHR data at UNC. And so this is really an entirely new paradigm of how we interact with EHR data and how we do research at least in biomedical data at UNC. Like I alluded to before, this is also a model that many of our peer institutions have already developed. So while this is new for UNC, it is maybe a bit of catch up compared to some other institutions. So this is also a model that I would say increasingly I see the NIH using for really large scale projects, largely through Palantir as sort of their choice of centralized enclave. And in many ways, what we are doing locally is modeled both in a structural way and a governance way on how the M3C Palantir secure enclave works. And so this is really, a from the ground up build of a high performance computing cluster built and managed by RENC in an ITS data center on campus that TraCS would then put de-identified UNC EHR data into. The PIs and researchers would then have direct access into that secure platform, and they would interact with the data directly. So as opposed to today, where you make requests to an EHR data team, you pay for that time and service, and you work with that team. This is a much more direct model for projects that this is appropriate for. So we have spent, in truth, several months doing all of the technical work with RENC, so building hardware and putting together software stack. And if we have spent something like 4 to 5 months doing the technical piece, we have spent more like 13 to 14 months doing the governance and the legal pieces of this. But really with the goal ultimately of having a modern data science sort of cloud-oriented environment that you will access securely through a browser to build your research within the secure enclave directly. And ideally, we would really use this pilot to demonstrate that this is a secure, workable, efficient model that we can start to use as a tool for other types of platforms and other use cases at UNC research. So then to move on from research engineering to education, this is really, this is a different focus, but I think if anything, education almost feels like the largest gap, both nationally and maybe to some degree locally. And it is a true priority, a discrete priority, both identified by me, by Emily, by TraCS leadership. And so this is certainly not a secondhand addition. This is a really primary component of what the Data Science Lab is about. And this is really focused on a pretty broad community. So this is not just students, graduate students. The idea is really to make data science and related healthcare relevant topics accessible to faculty, staff, trainees, students, with the goal of really trying to move everyone in a direction of becoming much more literate and conversant, if not experienced, with both sort of data science methods and concepts, as well as really modern sort of healthcare informatic concepts and topics. So even just a transition from sort of existing data models to using OMOP as your common data model is not necessarily a very small transition and requires a lot of additional sort of knowledge on architecture, concepts, vocabularies. And so a lot of this, is really intended to be run through the Data Science Lab as a place that really provides multimodal education. So that will include over time formal courses. So at times I have taught a really full semester length course on using EHR data for epidemiology. Emily teaches her own course in SILS in the CHIP program focused on using EHR data. But I think the idea is to go much broader than that and to have lectures, these seminars that we'll have every month, to also do hands-on experiences, really to just try to make healthcare data science education and training approachable and accessible in a variety of ways to a large audience. And so I have to touch on relationships. And so, I think there are questions of who does what at UNC, what organizations are involved, who knows what. Both from my really existing life at UNC, as well as collaborations, conversations we've already had. The data science lab either collaborates or works with actively or has existent relationships with a whole host of groups and in areas at UNC. Sometimes in large scale roles like RENCI, which is a very formal active partner with us, down to, smaller, such as, School for Data Science and Society. We know each other, exist at this point. We don't collaborate on much, but things change and develop. And then we're also sort of always growing this relationship pipeline, as one of the things we seek to do is really build much more of like a matrix network of groups and people and departments and divisions interested in healthcare data science, to have much more of a consortial working group, more formally developed at UNC, sort of in the healthcare data science space. You have a question? Can we hold off? I have, really, these are the end slides. So let me just hold off for like 2 minutes and then I'll get to it. Just to sort of move on to finishing up the content, I just wanted to share the common resources that we have right now. So we have a external public-facing website, external public-facing lab website that's accessible to anyone at tdsl.unc.edu. This has some information. I will say, though, this is fairly broad because it is fit for anyone, anywhere to be able to access. We also have an internal SharePoint for education and coordination. There's considerably more detailed and focused information in the SharePoint, which is only accessible to people on the UNC domain. So for instance, our listserv information is there. All of our seminar information is there. Links to the projects that we work on, educational training resources that we have, things that are maybe not as suitable for an entire external worldwide population to be able to focus, are really centralized through our SharePoint. So depending on what you're looking for, those top 2 links are sort of the important places to know. And to the best of our ability, I try to cross-link across each other. So even if you just remember one site, like the top level UNC website, there should be a way to get to whatever else you're looking for. And then we do also have a listserv for communication. If you're not familiar with Outlook or Office 365 distribution groups, you manage these yourself at this link. I also provide this link and a little bit of explanation of how to do that on our SharePoint site. But things like announcements for events, these talks, lectures, seminars, things like that, largely get managed through our listserv. And with that, I am Peter Lace. This is my email address. If anyone has questions that you think of following this. And I wanted to leave just about 15 minutes for any questions or anything else that anyone from chat or in person want to talk about. So thank you.
So we had 2 kind of related questions in chat. One was, how can people find all the links they're just showing after this talk? And when you're talking about education of the various courses that are offered around here, are those all listed separately?
Yeah, so links, I'll have to figure out whether these links can be, or I'm sorry, these slides can be approved to be posted to our like total external facing website, or whether they are considered internal only. But these slides will get posted either to our external facing website or a SharePoint or both. If helpful, I can also send those links out through the listserv. That only helps if people are on our listserv currently. Yeah.
Suggestion on that would be just send them to the people that mentioned about us.
start with.
We can do that. Not everyone is necessarily registered for this officially through the calendar. So I'm just trying to think about how do we capture 99%? Yeah. Yeah, I mean, I'm happy to send it out to everything that we have an email address for. Listserv, people registered through the event, all of those mechanisms, as well as posting these slides to the various sites. But then the second question was on how do we know about or stay informed on like educational offerings? So for that, I would say I am trying to keep certainly past education. I have posted to the website, and I think really both past and present or upcoming education, I'm trying to keep maintained on the SharePoint site as well. And then additionally, as they're sort of more timely, we are trying to send any of those out through the listserv. So depending on how far ahead you're trying to plan, I'd recommend either looking at probably mainly the SharePoint site, or if it's closer to an event, it'll come out through the listserv. The caveat to that might be like actual for-credit courses, but at this point, we don't have any of those planned. Yeah. It looks like somebody on the Zoom is talking, but I think they're muted probably. We might not have audio. Yeah. Yeah, I think on Zoom, it looks like in this room currently, we do not have audio through the speakers. And so I would recommend typing a question out.
Maybe switch using history about.
We currently are.
If you choose the icon, that would go in the room if possible.
All right, let's see if someone on the Zoom can talk to see if we get audio now.
This working?
No, still not.
Can you hear me now?
Yes, we can hear you now.
Yes.
It wasn't me before.
Well, great. Yeah, if you have a question, go ahead.
All right, that was probably just somebody trying. I have a question. So this is really exciting, and I'm going to try to limit myself to one or two questions so I don't take all the time. So trying to focus on which one is the most important. I'm really interested in the like moving towards a cloud-based infrastructure, in part because a lot of I've tried to do some things on SMW before, which we've been limited both because of the compute resources that are typically assigned and because of the fact that it's Windows based and there's software that's difficult for us to run there. So what is the plan going forward, or how do you foresee that being rolled out so that other UNC researchers can use that? And what kind of guardrails do you think will be in place to make the policy setters be happy with the protections for privacy?
Yeah, I'll be honest. That would probably require another hour-long meeting to discuss. It's pretty clear that UNC, from a privacy and a legal perspective, at least for sensitive data, and particularly for medically sensitive data, is extremely risk averse to any type of non-prem solution. And so truly, I say, like, We worked with Renzi, we built the hardware, it's in an ITS, not even like an off-campus data center, but an on-campus data center. And we are still in the middle of a year plus of discussion on legal and privacy and like information security review. And so, you know, I wish I had a better answer for you. I mean, what I can say is, as we sort of build things, if you are working or collaborating directly with the data science lab, that is without a doubt the way that I can most easily talk to you and try to facilitate some sort of working in these environments that we have. I don't know that I can promise any sort of access beyond that, like independent of working or collaborating with us. So like basically everything that we're designing or building for tech stack is for data science lab use or for our collaboration with people, as opposed to the building of a generalized high performance compute stack, which us plus any other researchers would be able to independently access. I cannot disagree that that's a need. I feel like it comes up often, but that is also a much larger conversation that needs to be
maybe
had.
a future meeting.
Yeah.
I mean, even in on-premises Kubernetes, or I'm assuming that's the way that it's going, or something along those lines, would be preferable, I think, than using SMW, using a VM-based system from a flexibility standpoint. So I guess it's a stay posted, see where things are, and I'll reach out when we have a next project we have that we might collaborate on.
Yeah, I mean, so I'm not sure like which area you're in, but I mean, if you want to, you can reach out to me offline. And so, for instance, like I can talk to you about, you know, what we have today or what we have built with Renzi to support ordered, which might be interesting or informative at a minimum.
All right, I'll reach out to you offline and we'll let somebody else ask questions.
Sure. Yeah. Yeah, no, but I mean, I would say every group that I meet with, that is a common topic of conversation, for sure. Yeah. Yeah.
Especially with ITS having a cluster already that works, but not accessible data.
Yes. Yeah. Yeah. So, I mean, we obviously Longleaf exists, but accessibility to it, particularly for HIPAA PHI data, is
So you talked a lot about research.
challenging.
What about the translational side, FH-FIRE or HL7, use for ways of actually interacting with real patients?
Yeah, so we have the benefit of relying on the existing TraCS teams. And so the more pure informatics pieces, we basically rely on them for. So my pretty focused target is for the data science lab to kind of do the pretty focused data science and modeling and pipelining work. And then software engineering, you know, transformation pipeline, you know, messaging, we would rely on the other teams for those pieces, either for scaling, deployment, implementation, anything like that. And the thing that's great is, you know, take FIRE, for instance, like they're already pretty good at FIRE. And so we can sort of rely on that as opposed to us as data scientists having to figure out FIRE for ourselves. Yeah. Any other questions on Zoom? Doesn't look like it. Okay. Well, again, just thanks everybody for attending. Appreciate your time, your interest. And if you are so inclined, feel free to, you know, go out to the SharePoint. I've already got some invitations and info up for the next two seminars for February and March. February is actually going to be led by JP, who I handed off a lot of our state death data, EHR supplementation, pipelining and linkage work to. And so JP is going to be talking about the sort of redevelopment of that within Azure, and now our production pipeline all the way out through our production data set for supplementing Epic data with external vital status mortality data. All right. Thank you, everybody.